Hello, welcome back to my solar upgrade. We're on phase 2, part 2 I think, the concluding part of phase 2. And it's all up, it's all done. It's all working fantastically. I got it all plumbed in a couple of weeks or so ago, and then I finished off in the battery room tidying it all up and properly doing it about a week ago. But this is the first time there's been a break in the weather, and I felt like getting outside and filming this bit, so here we are. I've now got, it's all working beautifully. I've now got more electricity than I know, literally got more than I know what to do with. I've been running heaters in the evening. Well, I've just been doing a load of mowing actually. This is actually Grandad's old mower, and it's doing the job. I have to say it's not the mower of choice for working around here. It's a hover mower, and it struggles to hover on stones and occasionally picks one up and throws it around. But it's getting the job done. I wanted to see what it was like as a proof of concept really, to do electric mowing, and it doesn't put a dent on the system at all, so that's another good thing. So in addition to mowing, other homestead things I've been doing with the electric power include sawing up the wood. So I've got my little battery powered chainsaw for going out some distance, but also this great big thing here has been fantastically useful. So this is a log saw, and you just chuck bits in there and run it through. And again, with the new upgraded system, it just doesn't put a dent on it, which is just when I installed solar initially, it was just to have some lights in the evening and maybe charge a laptop. I mean, that was my ambition. That was the ambitious part of the system, was to charge a laptop. And so yes, all this is quite exciting really. I'll show you in the battery room and try and talk through the setup. I did film putting it all together, but it was just such tedious footage, I just binned it all. I thought it'll actually be more pertinent, more interesting if I just talk through it once it was installed. So that's what we're doing a bit. I just want to show you first another dump load system, another use of excess electricity that I came up with, which is also working beautifully. I think I've got to that point now where I may actually know what I'm doing with some of this stuff. In the background there you can see the polytunnel that's currently got a big chunk of Project Kermit in it, the rear body, which I've been spray painting. And I've been spray painting that using the air that's contained in this massive receiver here. So this receiver stores the air at up to 105 psi, and then it feeds it down this line to this regulator, or it's a filter and regulator. This regulates it down to 30 psi and sends it to down another hose down to the spray gun. And because I've got this big reservoir of compressed air, it means that to power it I don't need a huge compressor like I've been using in the past. I can use a small compressor running for a long time ahead of when I want to do the spraying. We're now inside Kermit's carport. You can probably just about make out the air receiver just there. And this is the bit I want to show you, this little compressor. So this is cost me all of 70 quid delivered from eBay. It was second hand of course. This is what they call a silent compressor. Of course it's not actually silent. So this little compressor is permanently hooked up to that big air receiver. The first thing I did with this was pull it apart and find the little electric pneumatic switch, the cutout switch, and I adjusted that until it cuts out 105 psi instead of 125, which was its default. Just because that's what the gauge goes up to on the tank there. It's on this mechanical time switch. What that does is it allows it a 2-hour window each day. So I've set it to from 2 o'clock onwards. It gets a 2-hour window in which it can run for 15 minutes on, 15 minutes off to charge up the tank. Obviously if the tank is at full pressure, then this doesn't switch on at all. When I'm actually doing spraying in the polytunnel, I simply unplug it from here, from the time switch, and I just plug it in directly. There you can see it running, or hear it running rather. And it's pretty polite for a compressor. The reason I'm showing you all this is because this is in effect another dump load. It's not as swish as the other automatic dump load, which senses loads and switches on or off. This is automatic in a slightly different way, in a cruder way. but nonetheless this is another way of storing energy that doesn't need expensive batteries. It's just storing air in that giant tank ready for me to use it. And of course, if the air in that tank is always at 105 psi, I'm much more likely then to use my air tools, because I don't have to wait for a compressor to charge up its internal tank to be ready for use. It's always there. If I want to pump up some tyres or something like that, it's always there. It's just at pressure. If I want to, I can just do the paint spraying without waiting for the air to build up. I can just go and get on with it. We're now in the generator room, and what I just wanted to show you here is the big compressor. Now this is one of the most power hungry things I have. This is actually takes a lot more energy to start this than the welders do. This only takes about, I think it's just under 3,000 watts to run it, so like 2,500 to run it, but it takes 7,000 to kick it into life, which is, it never had a hope of running off of any of these previous systems. But now this actually works from the new inverter, which is fantastic. I never dreamed I'd be at this point where I'd be running this. Basically the upshot here, and the reason this compressor is still in use, is to run this, the blasting cabinet. So in recent weeks, when it's been sunny, I've actually run power to the generator room, not from it. So I've had to put in new 16 amp outlets for this, and now there's enough power during the day to run this big compressor, also to run the extraction system for the blaster here, plus all the lights, plus this big fan. it copes with all that, which is I was blown away by. It's not as good for blasting as it is running the diesel compressor, but it doesn't cost anything, and it doesn't have the absolute ball ache of trying to get the diesel compressor running, which is, it's always a mission. Even though I've done some maintenance on it, it's old and knackered basically. Yeah, with the electric things, they tend to just fire up. You can leave them for extended periods and then you can just fire them up, off they go. So although it's a bit slower doing the blasting with a fully electric setup, like I say, it costs nothing to run, which is nice. It's very nice. We're in the workshop now, and over there is a new consumer unit. It's actually the old consumer unit that was in the battery room, and I've installed it in here and put an extra circuit on it. So now on the workshop wall I've got an outlet and an inlet. So this is coming from the generator room to charge the batteries via this cable, but also now I can send it the other way. So I can just use this same cable, turn it around and plug in the generator room into the system. So we've made it to the battery room, and I'll try and talk you through what's going on in here without making it too technical or tedious. I'll try. What we'll do is we'll follow the path of the power. So we've got there's two arrays which made up phase 2, the array that's on the workshop here, which was existing, and the new array which is on the workshop. Obviously they face in different directions, so they come down and need to be fed into an inverter that has 2 solar controllers in it. So I think in the last episode, talking about all this, I showed you this thing. This is a grid tie inverter made by a company called SMA. It's been rebadged as Stucco, but it's made by SMA. Very well known, very sort of high quality German manufacturer. This was a waste of money. This has, in here, it has 2 inputs. 2 separate, well, they're not separate inputs, that's the thing, they look like separate inputs, but when I took the case up, it turned out the 2 sets of inputs, so there's 2 positives and 2 negatives going into this, but they immediately join up inside, which means they only go to 1 controller. So if I'd hooked up both arrays above us into this, it would be permanently confused as to what to do with the input. It wouldn't work. Not only that, the SMA grid tie inverters will lock. So when you set them up, You have to go through the commissioning process of setting it to a particular country and everything. And after 10 hours, that locks in place. And to change that, it's an absolute rigmarole. You have to register with SMA as an installer, so you need a company. You register with them as an installer, and then after a couple of weeks they send you a special code that you can input into it and get back to where it was when it started. Absolute palaver. This also has a lot of proprietary stuff going on, which I don't like. I really don't like technology that's very much closed systems like that. Anyway, I went back onto eBay and I bought this. This is a Solace Chinese make, one of the better quality Chinese makes from what I can gather. And what I like about this sort of thing, and obviously Chinese stuff has got a pretty dire reputation for the most part, but they are perfectly capable of making quality things. The nice thing about it is it's completely generic, and by that I mean that I was able to plug this into the system here. I was able to access the menus. I had full access. I didn't have to go through any registering with anybody as an installer or proving my worth with certificates or anything like that. As my machine, I was allowed to do whatever I liked with it, so I could access the menu here and I could simply tell this grid tie inverter that it was now going to live off grid and it was going to need to be controlled by an external source messing with its frequencies. Now don't worry about that for a moment. I'll try and explain that in a little bit, but essentially the point I'm trying to get across is this being a Solace, I could just set it up and it worked. I didn't have to, there was no rigmarole to it. It was easy to install. This has two separate sets of inputs. So this has two solar controllers in it, which means it's quite happy with the different inputs, the varying voltages from the two arrays. It treats them completely separately inside. So this, unlike these controllers, these blue box controllers here, what this inverter does is it takes the DC power coming from the panels at whatever voltage I can muster from there. It takes that and then it converts it into 230 volts AC and pumps it into the system. So this inverter is exactly as you'd have in a house, where it would provide power from the solar panels. It would provide that power to the house, and any excess power by default goes to the grid. In my setup, the excess power goes to the batteries, but you need a way of stopping the batteries then overcharging, and that's where the off-grid part of the grid tie inverter comes in. Because I've told this one it now lives off-grid, it will accept signals from this machine to tell it to throttle back, in effect. This machine, which is the new heart of the operation, this is the Victron Multiplus, and this is what had just arrived last time, and I think my explanation was a tad overexcited. The main function of the Multiplus, like the old inverter here, is to take battery power, is to take DC battery power, so 24 volts or whatever it is at that point, so roundabout, let's call it 24 volts, and produce 230 volts AC to power the entire system. That's its main function. Just like that was the main, this is the only function of this one. It's the main function of this one. This one is capable of quite a lot more. This is capable of charging the batteries as well as taking power from them, and that's why it can control this. I hope you're with me so far. We're going to go slightly more in depth now. This box here shows what's going on with the dump load. So we can see there it's in the automatic position, the relay is on, and so is the load. So the dump load is the immersion heater that's in the tank in the barn. The immersion heater at the moment is being powered entirely from this, not from the other solar panels. So these are basically idle at the moment, and I know this because I can see it up here on the readout. On this screen now we can see that the battery is completely full. The main solar banks are producing nothing. because there's nowhere to put that power, so they just shut down. We've got AC load of 791 or 800, round about, let's call it 800 watts. 700 of that is the immersion heater. The rest is just, well, whatever else is running at the moment, possibly the fridge. I've got the central heating pump on in there. So that load is entirely being covered by the PV inverter. Another big reason that I wanted to have a grid tie inverter installed in this system was for situations like lunchtime, where I now have the, and this is quite common, that I'll have the mini oven going, induction hob on, and maybe another induction hob with the kettle on as well, all at the same time. So I might be drawing 4,000 watts through that system whilst I'm preparing my lunch. If the sun's out and this is up and running, then some of that load, some of that 4,000, whatever the PV inverter can manage, that is load that is taken off of this inverter. And what that means is that it's just going from the panels direct into the AC system. That's the beauty of it. It doesn't have to go through all the rest of this. So the batteries, the controllers, the inverter, none of that's touched by that. It goes straight from the panels to the induction hob or the mini oven, whatever else I'm running. And it's the same, of course, when I'm running the air compressor and the blasting equipment over there, the big compressor. The small compressor, this setup barely notices. So what I'm trying to say is that on really big loads, it's not just going on this one instrument, it's sharing it. So this is taking a substantial part of that load. Another thing I did in here was upgrade the consumer unit. So the original consumer unit had 5 circuits on it, I think it was. This has got a whole bunch more. And see, we've got all the original circuits here, but I've got a couple of spares now. One of those will be the driveway, when I put some electric up there, because I've got an armoured cable that goes all the way up to the driveway. And still got a spare one. This here is an SPD. What that is, a surge protection device. And that's something that's usually fitted where there's a risk of spikes in the supply from lightning strikes and things like that. I've got it in here because it seemed to me a sensible thing to put in, because I'm switching big loads now. So if I'm, however good the inverters are, and they are really good, there's still a point at which, say if it's slugging away making 4,000 or 5,000 watts, and then I switch that off suddenly, the voltage may spike just for a fraction of a moment. This will mop up that over voltage without it going through the system. Already I've got, on things like the editing computer, there's surge protection 4-way sockets on those, but this is just a bit of added protection on there, so it should mean that there's no voltage spikes getting through. I think in practice I'm much more likely to get voltage spikes from a generator. Now the generator doesn't normally ever power the system directly, but it can in case of emergencies, which is what I'll come to next, because that's mainly what the rest of this setup is redundancy. So we'll finish off in here by looking at the redundancy aspect of it. This is something that I've always tried to include in my systems. So for instance, in the barn, right from the go, when I was installing lights and things in the barn, I also had a 12-volt lighting system, which is still in the barn. So it means that if all else fails, the lights stay on. In the same sort of mindset, I've got the arrays on the barn feed into 2 controllers. Instead of just putting all that load into one controller, it's split over 2. So if one goes down, we're not completely left in the lurch. Then there's an entire other system which is pulling in solar power. We've got the main inverter here, which does all the heavy lifting. Now I did talk about running these in a cascade mode, so that one inverter would feed into the other one and give me an absurd amount of power. I've decided to do away with that idea for the time being, because again, for the sake of redundancy and for the sake of simplicity, I wanted to use this one as a backup. So we've got inverter 1 and inverter 2 now. All that you need to do to change from one to the other, so if this one blows up for some reason. I'm not expecting it to. They're fantastically reliable, the Victron kit, but if it did, I would just have to turn this isolator on here to power up this one and then flip this big switch. And if both of them had gone, say if the whole battery system had failed for some reason, I would be able to fire up the generator and flip this switch. These are make, break, make switches, which means that they can't backfeed. It's basically it's one or the other, so it's either inverter 1 or inverter 2, or it's the inverter or the generator. But normally this stays on inverter 1, this stays on inverter, and it means that the generator power coming through here comes into this box, and then it goes to this charger and potentially to this as well, so I can put an enormous amount of power into the batteries if I want to, and if the generator's up to it. I think that concludes what I have to say about the new system. I've probably completely over explained it as usual. I have tried not to. If there's any questions, please do ask and I'll explain in even more detail. I'm quite happy to do that because I do, like I say, I do feel like I've got a grip on this now. Finally, I'm pretty happy with it. I'm very happy with it actually. Well, that's it for phase 2. Phase 2 is complete. I'm pointing over there to the battery room and to the workshop. Phase 3, well, it's not imminent, but it will be coming. Oh, as a side note, I last ran the generator I think in January. I'd be very surprised if I have to run it again before sometime in November. So you can see there that even though I spent what was to me a painful amount of money on that new inverter and indeed some of the rest of the system, it is all immediately going to start paying for itself. So in terms of the diesel saved, and well, I don't need any gas for cooking, for instance. So it's not just an indulgence, it is actually paying for itself. Anyhow, any more explanation on any of this, I'm quite happy to do so. Just let me know. Other than that, I'll see you next time. Cheers.